All right, today this is Math 2, Unit 6, Lesson 2, looking at similar polygons, and this is your homework help. We're going to take a look at numbers 2, 4, 6, 8, 9, 10, 12, and then 14, and we'll see how many more after that we'll kind of cover today. What we're looking at here says list the pairs of congruent angles and the extended proportion that relates to the corresponding sides for the similar polygons. Alright, so a few steps within each problem here that we're going to be taking a look at. And our first problem we want to take a look at is number 2, where we have two triangles, and it tells us that they are similar. We have triangle GHI as well as triangle, it says KJL. One of the things I want to do just real quick, just to help me visually see it, and maybe to help you too, is I'm going to go ahead and I'm going to rotate this triangle around a little bit, so that it matches what that one looks like. Okay, so I'm just going to redraw it. I'm not worried about the sides and how big it is. I just want to make sure looks the same. So I'm going to twist it around. I can see that my right angle was called J, so I'll write J there. On the short end, I had the L, so I'm going to put an L right here. And my tall top point was the K. Alright, so now I have two triangles that I'm comparing here. I already know that they're similar. I have GHI and KJL. Alright, you okay with that? Just making two triangles so I can see, oh, here's how they match up. Because sometimes it's just good to be able to verify those things. So now when I'm looking at finding the similar proportional or congruent angles, it's a lot easier. Angle G is congruent to angle K, straight across. Because I twisted it, now they match. So it's going to be angle K. I want to look at angle H is here, the right angle. So the congruent angle is going to be angle J. I have I right here on this side, the small side there, which matches up with angle L on that side. The idea of the extended proportion is that you write your proportion here, and we keep going until we basically get back to G. So think of it this way. I went G to H initially, then I'm going to go H to I. So I'm going to write HI here. Okay, so if I did K to J, my next part on the smaller triangle would be J to L there. And my last one is I to G, so I have I to G, and my last one here goes this direction, L to K. And you can see that H matches H, J to J, I to I, L to L, and the G actually matches where you started with over here, this G, and that K matches that K. So that's what an extended proportion looks like. It just goes on. If it was a parallelogram of some sort like you have with number 1, then you end up with a fourth piece, right? So you have AB, BC, CD, and then DA. And that's how that's going to work. All right, let's look at number 4. Number 4, it says determine whether the polygons are similar. So we have to decide, are they or are they not? We don't know. They might look similar, but until you set up your proportions, you can't verify that. If so, write a similarity statement and give the scale factor, and if not, explain why it's not there. So in this section, you have 4 different ones that you're going to look at and determine whether they're similar or whether they're not. I'm going to go and look at number 4 first of all. Alrighty. So we have this shape here. We have 8, and we have a 12. We have a 3 and a 4. Couple things that I can do with this here is I can look and say, well, if I wanted to twist this one and maybe like knock it over on its side, I could do that just for fun. So let's knock it over on its side real quick and redraw it. So my right angle goes there, so I'm just kind of pushing it over there. And I'm going to relabel. I have U, I have T, I have V. When I knocked it over, my tall side became the bottom, which was a 4. And the part that was the bottom flipped up and became a 3. So now I can look at my different pieces, and we're going to match them up and see, are they forming a proportion. So let's start with our tall point now. I have an 8 to my bottom part 12, and if it's proportional, then I'm going to say that it's going to be equal to 3 over 4. 3 is my tall part, matching that 8, and 4 is my bottom or base, matching that 12. 8 over 12 can be reduced. I know from just mathematics, 8 divided by 4 is 2, and 12 divided by 4 is 3. So now we're asking ourselves is, does 2/3 really equal 3/8? Well, the obvious answer is no, it doesn't. Those are two different things. They can't be reduced anymore, so they would have to match if they can be reduced, if they couldn't be reduced anymore, and they don't. The way you might want to check that if you weren't sure is you could cross multiply. 8 times 2 is 16, and 3 times 3 is 9. And if you remember way back in the day with comparing fractions, you would actually go, oh, that one's larger, so that one's actually a larger fraction. But that's another story. So we can say that, nope, they are not similar, and the reason why, my explanation is, they do not have congruent sides, or their sides are not proportional. Okay, or sorry, their corresponding sides, I would say, corresponding sides are not proportional. Okay, based upon doing that similarity statement. Let's go to look at number 6. 6 is a little more fun. We have, I know, fun for me, maybe not for you, that's okay. We have a 49 and a 43. We have 49 and a 40 and an 88. I'm going to zoom in a little bit because it's hard to see on my little paper there. Don't worry, it's even blurry for me with it without the dot cam. So I'm going to rewrite it just so you can see it here. We have 49 and we have an 88 and we have a 43 and we have a 49. A couple different approaches I could take with this. I could look at the lengths and compare the lengths. I could also look at the angle measurements and compare the angle measurements. Okay, so there's two ways of doing this problem basically, and it's up to you which way you want to go. I'm going to go ahead and do the angle measurements just because it takes an extra step. I want to make sure you understand how to do that there. So because it's a triangle, I know that every triangle has 180 degrees. So if I want to determine what this missing angle measurement is, I could do 88, what's given, plus the 49, again what's given, and I end up with 137. To find out what's missing, I would do 180 minus 137 to figure out there that what's missing is 43 degrees. So this angle measurement is 43 degrees. So if that's 43 degrees, I look over here and go, hey, so is that. Well, what's missing from this one? 43, 49, I could do it again. And we have 92. And if I do 180 minus 92, we end up with 88 degrees. So this missing measurement is 88 degrees. So looking at it, what I have is a triangle with 88, 43, 49, and another one with 88, 43, and 49. My angles are all the same, which tells me most likely I have a pair of triangles that are going to be similar. But just because we're here, I notice that I also have lengths on all of these, 6, 9, and 12, and 4, 6, and 8. So let's just pick a couple sides to compare. Let's go from the 88 to 43 side is 9, and then from the 43 to 49 side is 12. Over here, I want to keep it with the 88 to 43. 88 to 43 this way is the 6, and then going around the triangle from 43 to 49 on this case is 8. And you just have to ask yourself, do they reduce to form the same proportion? 9 over 12, that can be reduced by 3 divided by 3. 3 goes in there 3 times, 3 goes in there 4 times. Over here, I see that 6 over 8, 3 goes into here. Sorry, 2 goes into there. Apologize. 2 goes into there 3 times, and 2 goes into there 4 times. 3/4 does indeed equal 3/4, so we would say yes, these two shapes are going to be similar, and our scale factor is 3 to 4. All right, we good there? So CD 12, double checking here, CD is 12. Look at my notes, and they just look a little funny. 12, and we have 8. And, I think I did something not right there. My answer says 3 over 2. So what did I do wrong? Let's see. Oh, because that's my ratio, is 3 over 2. Checking real quick here. Hang on a second, guys. Apologize. So my ratio is one side to the other side. So we can compare. Let's take CD, and we'll compare CD to IJ. This is how you're going to write your scale factor. So CD happens to be 12, and IJ is 8. My apologies. This is how you find your scale factor. That made it equal to each other. Scale factor, pick a side. Just pick a side, CD, and find the corresponding side. And then we can reduce that down. 4 goes into there 3 times, and 4 goes into there 2 times. So this is our actual scale factor. Scale factor is 3 over 2. Sorry to be a little confusing there. Sometimes when I look at my notes, I just mess myself up. It happens. All right, number 8. Looking at number 8 here. We have a crazy little shape. I have to determine if it's similar or not. This is the letter B. We have the letter A over there. And then I have the numbers 9, 15, 12, and 10. Okay. To see if these are going to be similar or not, we recall that this line here, I believe they call it a transversal, it goes across here, tells me those angles are going to match. I have vertical angles here, so these angles are going to match. So I know that those are going to be equal to each other in that way. Now I need to decide, okay, do the sides match here? I have 3 measurements for this triangle and only 1 for this one. I know because the angles match that most likely these are going to be similar triangles, but let's just make sure. I'm going to go ahead and take my small side over here, A, and put it over my longer side, 9, and I'm going to make it equal to the opposite side over here is 12, okay, because it's not just, they're going to be this one, that'll be the different one, because we take it and almost like flip it like an image. So set it equal to 12, and then the opposite side over here, this transversal line, is 15. And from there, I can go ahead and either cross multiply and solve, or if you want to, it might be a little easier sometimes just to reduce it first of all, and then cross multiply. So 12 and 15, I can recognize that once again, 3 goes into here 4 times, and 3 goes into here 5 times. So now I have a little bit smaller number to work with, 4 over 5. I can cross multiply, and I have 5a. Oh, sorry about that once again. Then we have 5a equals 9 times 4, 36. And yes, it's an ugly number. Divide both sides by 5, and we find out that a equals 7.2. Okay, so that's the A portion there. It does also say to find the value of each variable. So don't just stop there. Now we need to go back and do the B variable. So I'll do the same kind of thing like I just did. I'm going to do the base over here, B, and make it over what I know, the 9, and make that equal to the base on this side, which is 10, over the opposite of the 15 there. 9 is a 15. Like I did last time. Oh my goodness, I'm doing it again. I'm going to zoom out. Sorry. Just not very good at this sometimes. So I have, sorry, B here to the 9 and the 10 to the 15 to set that ratio there. I can reduce, 5 goes in here 2 times, 5 goes in here 3 times to make my cross multiplying a little easier. So 3b equals 9 times 2 is 18. Divide both sides by 3, and b is going to equal 6. So my value of a is 7.2, my value of b is 6, and now I've solved that equation. Let's turn the page. We'll look at a couple more of these before we wrap this one up. Looking at number 9 first of all. Again, this is worksheet K. It says you want to enlarge a 3-inch by 5-inch photo. The paper you'll print on is 8.5 by 14 inches. What is the largest size the photo can be? Okay. The way I set this one up is I said, well, I'm already working with a 3 to 5 ratio to start with, and I'm going to go ahead and make it the size of the paper. In this case here, I know the largest it could be in one sense would be 14, right? Because that's the size of that paper, 8.5 by 14. All right, so it's going to be a 14 there. I know it can't get any bigger than 14 because that's the size of the paper I'm working with. So I'm going to use that 14 there to work with and make my top value equal to x to see if I can figure out what would be the width of the paper, my other number. If I can use all the 14, what's the most of this portion of the paper I could use is what I'm trying to figure out there. So I end up with 5x equals 14 times 3, which is 42. I divide both sides by 5, and x equals 8.4. So the largest size photo that I could use would be an 8.4 inch by 14 inch would be my largest enlargement I could use. I can almost use that whole thing and have a little bit of space there basically. For the art class, number 10, you need to make a scale drawing of the Parthenon using the scale 1 inch to 5 feet. 1 inch to 5 feet. The Parthenon is 228 feet long. How long should you make the building in your scale drawing? So our scale that we're working with is 1 inch goes to 5 feet. Correct? Well, what we do know is that we don't know the scale drawing size. That's our x. Our scale is going to be the inches. But we know that our real one is 228 feet long. So 1 inch goes to 5 feet, and I don't know how many inches in my model will go to 228 feet, the actual size of the Parthenon. But I'll cross multiply again and get 228 equals 5x. I'll divide both sides by 5 to determine that x equals 45.6 inches. So I used my scale that was given in the problem, 1 to 5, and I did that. I didn't convert it. There just wasn't a need to convert it for this problem because that's not what it's asking you to do. It doesn't want them in the same formula, or the same value. You're just saying it's 1 inch to 5 feet. That's a scale drawing, just how it works. All right, number 12. We have a scale factor once again. These two triangles are not facing the same direction, so if you wanted to turn them sideways, you certainly could, like I was showing you earlier. You can just stand that one up or tilt that one over so the sides match. It's not too bad with a triangle, but you will find some shapes later that aren't as easy to visually see that which parts match. Sometimes what I like to do is just even color them. So I know that this part here matches this part here. And then I know that this is my tall part from the right angle matches this tall part there. Just so I can see with colors what matches what. I've got green, blue, green, blue. So now it says to find the scale factors of the polygons here. Find the value of z first of all. So let's find the value of z. To find the value of z, we're going to say tall part, 3, to the short part, z, equals the tall part there in blue, 9, to the short part here, z plus 4. So I end up cross multiplying. 9 times z is 9z, and that equals 3 times z plus 4. I'm going to use distributive property to break this apart. Sorry, yeah. And we have 9z equals 3z plus 12. Let's subtract 3z on both sides. Same with 6z. Oops, I wrote an x, so I used to write x's. 6z equals 12. Divide both sides by 6 to determine that z equals 2. So I know my value here is 2 for the value of z. Make it better 2 there. There we go. And it wants to know what my scale factor is going to be for this problem here. My scale factor, I have a couple ways of looking at it. We want to make sure we're looking at the opposite, the same kind of lines like we did before. The one I messed up a few minutes ago. So let's say, for example, I have k to j. In this case here, I have k to j. Then I also have r to q. The value of k to j is 3. The value of r to q is 9. So my scale factor is 1/3. So this time I did a lot better without blowing the whole thing like last time. So scale factor, I'm looking at the blue to the blue. Set them up, make the fraction, reduce it, and you're done. Last one here, I said do number 14, maybe a little bit more. We have some time. We've already been about 21 minutes running in the cycle, so let's see what we have. There's a scale factor of NOP to WXY, finding the scale factor there to start with. To find that scale factor, I can take a side length here. I can say, all right, I have a 4, I have a 6, I got a 4, 6, I don't know, I have a 10 and a 12. So let's go ahead and it says that, well, it says that NOP is equal to WXY. So because the letters go in the same order, going this way, that tells me that this base right here corresponds to this base right here. If the order of the letters had been different, I might have to maybe, flip one of these over and write it a different way. But they all said NOP, so we're going around the triangle this way, and then WXY going around the triangle this way. So my base of this one is 4, my base of this one is 10. So this is going to be my scale factor of NOP WXY. I reduce that down to 2/5, and that's my scale factor for that one. Then when it comes time to find the other parts, they gave you enough information to solve that. So the measurement of x, well, if x is here, its corresponding angle is over here at O, and O it said was 58 degrees. So we could say that it's 58 degrees. For the measurement of y, which is over here, I get this one over here. Well, they didn't tell me what that was. So, think back to what we did a few problems ago, the one that I messed up a little bit. Let's see. I can see what's missing by doing 58 plus 49 is 17, carry the 1, 107. And now that's not what's there, that's what I've used out of 180. So let's do 180 minus 107, and what that tells me is that when I borrow, 10 minus 7 is 3, 7 minus 0 is 0, sorry, 7, I have 73 degrees left in that space for P, which is also what I have left for Y, is 73 degrees. For 17, they want you to write NP, which is here, and WY, which is there. Well, they didn't give me NP, did they? Nope. Didn't do it. Do I know what it is? Sure. I can figure it out because I know what the scale factor is going to be. NP is going to be this way. We have 2 to 5 is our scale factor. Yeah? We know that. Got it. Scale factor. Here's how we use it. WY, I know WY is 12. So I don't know NP, so we'll call it X. And now I cross multiply to solve for x. I'll leave that one right there just as it is. For wx, which is this one right there, I need to do the same type of thing. Okay, that again, it's 2 to 5 is my scale factor, right? Wx. I knew that in this case here, O was 6. That's my smaller one, right? So my small triangle, which is the 2, I had a 6 on that side. My big triangle, I don't know, I have an x. So I would cross multiply again to find out what Wx is going to be. And then for the NP, to find out what NP would be, I would do the same type of thing once again. Okay? So to find NP, I would just go ahead and do what I did right here to say, oh, NP is 4.8. Now I have a number for 4.8, a number for WY, and I can make that all work together. So there's a few steps in there. That's not totally done. You'll have to do some more work there to figure it out, but it's close enough to get you started, and I hope that helps.